Sorry. Yeah. So in the previous class, we have discussed, right? So how to calculate the circumferential stress, longitudinal stress, and the shear stress as well, right? So isn't it? So along with that, so what will be the stresses when a cylinder is having a hemispherical ends on the both sides? Okay. So even that also we discussed in the previous class. So based on this, we are going to solve few problems. Okay. By that we can close these thin cylinders. Okay. So so with effectually we can start the thick cylinders from the next class. Okay. So first let us write what are the formulas required to do problems on the thin cylinders. So by that we will solve few problems on this. Okay. So based on that we can continue with the next topic in the third module. Okay. So let me share the screen and let me write the problems, formulas on the board. Yeah. Thin cylinders. So first one, so when the cylinder is having a cylindrical cross section and where the ends are with a straight edge, okay, so without any hemispherical shape at the ends. So let us take the cylinder like this, okay, so which is having a thickness of this. Yeah, students are joining now. Okay, so this is how the thin cylinder looks like. So what is the first statement, Amma? How you are going to decide whether the cylinder is thick or thin? How you are going to decide whether the cylinder is thick or thin? Based on its thickness. Internal diameter. Yeah. So based on it, internal diameter. So this is your internal diameter D, and the external diameter is capital D. Right? Yeah. So from this, the first statement itself is when the internal diameter is less than 1/20th of its what? So the internal diameter, so D by 20. So when it is less than or equal to D by 20, so then you can able to consider it as a thin cylinder, right? So what are the formulas we derived here? So when the cylinder is like this, or when a vessel or any kind of cylinder which is having a closed ends, so where the ends are circular in cross section in this way, right? So where the cylinder is going to subjected with few stresses. So what are those few stresses? First one is circumferential stress, or it can also be called as a hoop stress. Okay, what is that stress, Amma? PD by 2T, right? And the next one, where the cylinder will have the longitudinal stress. Guys, so please mute yourself. So this is a longitudinal stress. Okay, so the longitudinal stress is PD by 4T, and there will be another stress, so which is a shear stress. Why? Because if you take any particular strip or a shell in this, so the stresses are mutually perpendicular to each other. Okay, so there will be a shear stress, so which will act along with these two particular stresses, so which is called as a shear stress, so which is sigma C minus sigma L by 2. So by that you are going to get your shear stress as PD by 80, right? So here we can able to conclude your circumferential stress is 2 times the longitudinal stress, isn't it? Okay, so where the circumferential stress is the maximum, so where it is going to, you know, create a failure. So can anyone tell me what kind of failure the circumferential stress will create and what kind of failure the longitudinal stress will create? The circumferential stress will make your cylinder split. Okay, your circumferential stress makes your cylinder split into pieces, and the longitudinal stress makes your cylinder burst. Okay, and at these ends there is a possibility of bursting due to the circumferential stresses. The failure will be splitting. Okay, so that is what we have to understand. So when there is you know, members which are subjected to these kind of stresses, right? So this is what we discussed in the previous class. Along with that, have you all understood this, Amma? Yeah. So you formulas note cheskunnaru kada? Yeah. So next we will write the formulas based on the strains and the same cylinder when having an ends of hemispherical shape. Okay. Yeah. See, this is the way when we complete any module, you have to place all your formulas at one place. Okay. So by that you can able to revise them easily. So this is another cylindrical section. Okay. So where the ends are hemispherical in shape. So it is also having a circumferential stress. Okay. It is also going to have a longitudinal stress. But the thing is, the thicknesses will have a difference. Okay. So this thickness we call it as a T1 and this thickness we call it as a T2. Okay. So here when we try to calculate the circumferential stress and longitudinal stress, so here there will be circumferential strain which gonna takes place in the cylindrical portion and the circumferential strain which is gonna takes place in the hemispherical portion. Okay. So this portion is cylindrical portion. Okay. And this portion is hemispherical portion. Hemispherical portion. Okay. So can you tell me what strains takes place? Because we all know stress is, Young's modulus is equal to stress by strain. So strain is equal to stress by Young's modulus. So here, as we discussed, the circumferential strain, okay, so which taking place in cylindrical portion is considered as C1, so which is PD by 4 T1 E of 2 minus mu, and the second one, the circumferential strain at the hemispherical portion is PD by 4 T2 E of 1 minus mu. Okay, from this only we have derived the thickness of hemispherical portion will be 0.5 times of the thickness of the longitudinal thickness of the cylindrical portion, isn't it? How we have derived this? So here there is a statement, in order there is no distortion in the member. So the member is not under failure, isn't it? So when there is no distortion in the member, we can consider the strains in the cylindrical portion will be equal to the strains in the longitudinal portion. Okay. So by taking the both the strains are equal, by equating these two, you are going to get T2 by T1 as 1 minus mu by 2 minus mu. I think this is the formula which we have used for calculating the thickness at the hemispherical portion, isn't it? E problem right? So this is the problem where, this is the formula where you are going to use to calculate the thickness at the hemispherical portion with the help of Poisson's ratio. With the help of Poisson's ratio. Understand? So this is very important just to calculate what is the thickness at the hemispherical portion by knowing one thickness at the cylindrical portion. Understand? So with this we can do. Or else, as I discussed one more formula, so where T2 by T1 is equal to 0.5. So where T2 is equal to 0.5 times of T1 and got to discuss chesam, right? Isn't it? Yeah. So without having any Poisson's ratio, so how can we get the thickness at the hemispherical portion? So by having this. So here we have to understand one statement. The hemispherical end is always having a very thin than the cylindrical portion. So where the maximum stresses may be same in both cylindrical and hemispherical portions. Okay. So the stresses are going to be same. Whatever the stress acts in cylindrical portion, the stress will be same even in the hemispherical portion. So by equating the two stresses, so which is like this. So at the cylindrical portion, the stress will be PD by 2T1. What will be the stress at the hemispherical portion? What will be the stress at the hemispherical portion? 4T2. By equating these two, what you will get? T2 by T1 is equal to 0.5, isn't it? Yeah. So this is the stress which is acting in the cylindrical portion, and this is the stress which is acting at the end in terms of a longitudinal stress, right? So that's how this is going to be achieved. So whenever you find any problem which is related to the hemispherical cylinder, you have to remember these formulas to solve the problem. Understand? So basically they're going to ask you to calculate the thickness, but coming to the stresses will be same. Okay. The only thing is at ends the stress will vary. Sorry, at end the thickness will vary. As it is a hemispherical portion, the pressure distribution will be more. As the pressure distribution is more, no need to maintain the same thickness what you are maintaining at the cylindrical portion. Understand? So this is the another one where you have to remember the formulas to solve the problems, right? Next immediately we have solved few formulas to calculate the strains in thin cylinder, isn't it? What are the strains in the thin cylinder? So let us write first one, longitudinal strain. So I think in the previous class we already discussed how to achieve the longitudinal strain, isn't it? So can you tell me what is the formula for the longitudinal strain, Amma? Epsilon L. Can anyone? What is the formula for the circumferential strain or hoop strain? What is the formula for longitudinal strain, circumferential strain and volumetric strain for a thin cylinder? In the longitudinal strain. So previous
PD
class,
by 4-2E.
yeah, PD by
4-2E, 1 minus 2.
1 minus
2.
With respect to what? With respect to length, right? Yeah. So next, what is the circumferential strain?
PD by 40E, 2 minus mu.
Exactly. This is with respect to
Diameter.
So it can also be written as PD square by 4TE of 2 minus mu. Okay. So so diameter it's d square. And what is the volumetric strain?
PD by 40E, 5 minus 4 mu.
4 mu with respect to volume. Right. So this is how we can able to calculate strains in a thin cylinder with the help of these formulas. Okay. Yeah. So please try to remember all this. Ivanni raskovalama. Raskunte solving problems will be very easy. Even in your competitive exams, if you remember all this, so you can able to attempt easily. And next one, very important, thin spherical stress under internal pressure. Because in your syllabus, there is a spherical shell also there. Okay, apart from the cylinders, there is a spherical shell. What do you mean spherical shell? So let us consider anything which is stored in a shell. Okay, shell ante, so it's like a cubical, sorry, it's like a spherical shell, oka ball laga anamata. Okay, so what will be the stresses in this? Deentlo stresses ela untayi? So it is something like a ball. Okay, so if you consider this spherical shell, let me draw the same in 3D. If you cut this section here, okay, it's a solid spherical shell. So when you cut this section, it looks like this. Yeah. So whatever the internal pressure is going to be acted inside the spherical shell, how this internal pressure is going to be considered? Can anyone tell me what stress will be there in the spherical shell? Amma? Okay, round circular spherical shell lo em stress untundi? Okay, you tell me, is there any longitudinal stress in the spherical shell?
No, sir.
Why? Because it doesn't have any length, right? So spherical shell will have only diameter. So by that, your longitudinal strain or longitudinal stress will be zero. There will be only circumferential strain or stress or only a hoop stress. Okay, ఇది ఒక్కటే ఉంటుంది. అది కూడా ఎలా యాక్ట్ అవుతుంది? So your pressures will be distributed like this in all directions with respect to its circumference. ఈ విధంగా spherical shell లో మొత్తం pressure అనేది ఉంటుంది. Okay, and even here also the pressure will be like this. ఎందుకంటే సర్క్యులర్ బాల్ కాబట్టి అది. ఓకే, ఇట్స్ సర్క్యులర్ అని చెప్పకూడదు, ఇట్స్ స్పియర్ కాబట్టి స్పియర్. ఓకే, సో హియర్ హౌ టు క్యాలిక్యులేట్ దట్ సర్కంఫరెన్షియల్ స్ట్రెస్ ఇన్ స్పెరికల్ షెల్? వాట్ విల్ బి ద సర్కంఫరెన్షియల్ స్ట్రెస్? ఎంత ఉంటుంది? హౌ టు క్యాలిక్యులేట్ దిస్? సేమ్ హౌ వి క్యాలిక్యులేటెడ్ ద ప్రీవియస్ వన్స్, యూ హ్యావ్ టు డూ ద సేమ్. ఫస్ట్ వీ షుడ్ నో వాట్ ఈస్ ద ఇన్నర్ ప్రెషర్, and next what is the resisting thing we have to do. First tell me what is the internal bursting force. ఎంత ఉంటుంది మా internal bursting force? Same, pressure is equal to force by area. From this, what will the internal bursting force? Pressure into where this internal bursting force is acting, at its cross sectional area. Antena? Right? Ide kada, this force is making, this is the bursting force which is making your sphere to burst, right? So this force is acting at its cross section, right? So then your cross section may choose the along, it's a circular cross section, isn't it? So same like this. So with respect to dia, where it is acting? At its cross sectional area. And next, what will be the internal resisting force? ఎక్కడ యాక్ట్ అవుతుందో internal resisting force? internal resisting force will act at which point? At its internal resisting force ఎక్కడి నుంచి యాక్ట్ అవుతుంది? ఏరియా మీద యాక్ట్ అవుతుందా, సర్కంఫరెన్స్ నుంచి యాక్ట్ అవుతుందా? So you should tell them
circumference.
Exactly. Why? Because always the always a sphere, the resistance will be with respect to its circumference. Okay, so if you take the sphere section like this, okay, resistance eppudu on its circumference it will be there. Okay, total circumference మీద ఉంటుంది అన్నమాట. So when it is acting in the circumference, then what will be your internal resisting force? Pi d is your circumference with respect to what? Thickness. So this is your area, avuna, into stress. This is your internal resisting force, area into stress, circumferential stress. Equate these two. What is your circumferential stress? PD by 4T. ఇదే ఫార్ములా వేరే దానికి ఉంది. దేనికి చెప్తారా? The same formula which we use for calculating what? Longitudinal stress for cylinders. అవునా? సో చూసారా, cylindrical shells అయితే longitudinal stress లో your stress will be PD by 4T. అదే spherical shell లో your circumferential stress itself is PD by 4T. Okay, don't get confused. Ardhamavutunda? So this is for sphere, right? So this is how the formulas we have to remember, for solving the problems. If you find any problem which is having a thin spherical shell అని ఇచ్చారు అనుకోండి, so you have to calculate only the circumferential stress with the formula of PD by 4T. Understand? So these are the formulas which are required to calculate the stresses in different ways, like cylindrical shell kanivandi, hemispherical ends kanivandi, or a thin spherical shell kanivandi. Okay, next, there is a possibility to ask even the efficiencies of the cylinder. Okay, efficiency of the cylinder. How to calculate the efficiency? So here ఒక్కొక్కసారి ఎగ్జామ్స్ లో, ఈవెన్ కాంపిటేటివ్ ఎగ్జామ్స్ లో కానీ గేట్ లో కానీ ఎఫిషియన్సీ అడిగారు అనుకోండి. సో ఎఫిషియన్సీ యూ కెన్ ఏబుల్ టు క్యాలిక్యులేట్ ఫర్ ఎ సిలిండర్ ఇన్ 2 ways. One is longitudinal efficiency, other one is circumferential efficiency. So with the formula PD by 2T of neta, efficiency C. Okay, sorry, efficiency C. Longitudinal stress అనుకోండి PD by 4T of neta L.
సార్ అది రివర్స్ వస్తుంది అనుకుంటా సార్.
ఓ సారీ, యా సారీ, నేను ఇక్కడ డైరెక్ట్ రాస్తాను కదా, సారీ. యా, efficiency we calculate with respect to so circumferential. If you want to calculate the efficiency of the longitudinal stress, so this will be your L and this will be your C. Yeah, so this is how the efficiency you are going to calculate for a cylindrical and the longitudinal stresses. Okay, ee rendu formulas kuda you have to remember, right? Yeah, so I think almost we have covered all the formulas there in your what is that, thin cylinders. And one more important formula, your volumetric strain okay. So volumetric strain key, if you want to calculate it directly, okay, you can use this formula, which is an algebraic sum of net strains in all the axes. So volumetric strain and enti, so it will be a summation of longitudinal strain plus circumferential strain. So how you can write this, there will be a net longitudinal strain plus 2 times of the net circumferential strain. So మీరు ఇందాక strains formulas ఉన్నాయి చూసారా, even with that also you can able to do it same way, plus 2 times of this. So even you can make use of this formula to calculate the volumetric strain, which is the summation of longitudinal strain plus 2 times of the circumferential strain. Okay, so even with this also you can able to calculate the volumetric strain directly. Okay, yeah. So this how there is a possibility to ask you, for solving the problems. So let's do 2 problems. Okay, so I think these formulas direct man substitute cheste vastayi. So let me show you the questions. So by that we will solve it. So by that we can close this thin cylinders. Very easy, amma. The only thing is we have to understand the concepts, how these formulas are achieved, and how these stresses are going to be acted in the thin cylinders which are having a closed ends, thin cylinders which are having a hemispherical ends, and what the stresses acting in the sphere. Okay, spherical shell anamata. Have I downloaded that or not? I didn't download, I think. One second, let me download the problems. Is the screen shared, Amma? Not.
No, sir.
No? Right. Yeah. One second. So let me download the problems. I think I have shared you the notes, but anyway. Yeah. So is the problem visible? Right? So this is your first problem. Calculating the bursting pressure for a cold drawn seamless steel tubing of 60 mm inside. Okay, diameter with 2 mm wall thickness. The ultimate strength of steel is 380 meganewton per meter square. So let's see the problem again. Calculate the bursting pressure for a cold drawn seamless steel. So here you have to be very careful. When the problem is given, first you have to know which stress will make your cylinder burst. అనేది మనందరికి తెలియాలి. Okay, by that you can able to make use that formula, right? So bursting pressure for a cold drawn seamless steel tubing of 60 mm inside diameter with 2 mm wall thickness, and whatever the dimensions are given also very important to calculate that. Okay, so let me write the given data. So by that we will solve the problem. What is the given data? The first one, the diameter of the seamless steel cylinder was given as D is equal to, what is the diameter, ma? 60 mm. Yeah. And next, what is the thickness of the cylinder given? 2 mm. and the ultimate strength of steel is given as 380 meganewton per meter square. Okay, so which is an ultimate strength. So in cylinder, which stress will be the ultimate stress? Which stress will be the ultimate stress? Circumferential stress or longitudinal stress? Which is the maximum one?
Circumferential, sir.
So this is your maximum stress and this is your minimum stress. మరి ఇక్కడ ఇచ్చింది ఏంటి? అల్టిమేట్ స్ట్రెంగ్త్ ఆఫ్ స్టీల్ ఇచ్చారు. అల్టిమేట్ స్ట్రెంగ్త్ ఆఫ్ స్టీల్ అంటే ఏంటి? Fu, right? Okay, now you tell me. So in the cylinder, which is having a definite thickness, okay, so when the pressure is acting like this pressure is going to be resisted by which material? లోపల ఉన్న ప్రెషర్ ని ఏది రెసిస్ట్ చేస్తుందమ్మా? స్టీలే కదా, రైట్? సో దిస్ మెటీరియల్ విల్ హ్యావ్ ఏ రెసిస్టింగ్ stress. So by that, so to resist the circumferential stress over here, this material steel also should have an equal or more than resisting stress. Then only your cylinder is not subjected to bursting, right? So by that, I can consider your ultimate stress, which is ultimate stress of steel, which is equivalent to the circumferential stress of cylinder. Okay, I can take these two are equal. Why? To make this equilibrium. Equilibrium ante em ledhu, failure avvakunda. Okay, so by considering this, what is your circumferential stress formula? PD by 2T P into pressure is not given, and what is the dia? 60 mm. So convert that into meter. Why? Because your stress is in meter. Entamma 60 meter and 60 mm ante 0.06 by 2 into what is your thickness? 2 mm. 2 mm ante 0.002. What is your stress? 380. Okay, mega ante 10 power 6. What is your pressure here? What is the pressure? Anyone calculated? You can tell your pressure in mega newton per meter square, or you can tell it in newton per meter square. Anything is fine. So what is the pressure? What is the internal pressure which is acting in the cylinder to have a resisting stress of 380 meganewton per meter square?
25.33 into 10 to the power of 6 Newton per meter square.
25.33 meganewton అని రాయొచ్చు, లేకపోతే 25.33 into 10 power 6 Newton per meter square అని కూడా రాయొచ్చు, right? So what it means? See, solving problems is very simple just by knowing the formulas, but you have to understand what this pressure is indicating. ఎందుకు క్యాలిక్యులేట్ చేసాం ఈ pressure? This says that the pressure inside the cylinder of 25.33 into 10 power 6 Newton per mm square, sorry, meter square, is creating a stress on the cylinder of 380 meganewton per meter square. Then your cylinder won't get burst. Okay, bursting jaragkunda untundi. Ade meeku pressure, if it is more than this, more than 25.33 into 10 power 6 undanukondi, okay, what happens? There is a possibility of burst in this material, like steel may gust, steel cylindrical may get burst. Okay, so that's how even you can do either one. You can reduce the pressure to control the bursting in the cylinder, or you can increase the ultimate tensile stress of the steel material to control the pressure, which is more than 25.33 into 10 power 6 Newton per meter square. So this values states that when you design your cylinder, if whether you want to increase the ultimate tensile strength of the steel, or whether you want to increase the whether you want to decrease the pressure to match with the tensile strength of the steel అనేది మనకు చెప్తుంది. Okay, so that's the reason why. So you can calculate all the values and you can give to the designer whether you want to reduce the pressure or whether you want to increase the resisting strength of the steel material అనేది we have to understand from the problem, right? So this is how the problems will be given. అంతేగాని so simple గా మనం ఫార్ములాతో ఆన్సర్ చేసేస్తే సరిపోదు. Okay, so even we have to know the end, so what we can understand from the problem. Okay, right. So let's have another problem. Yeah, so is the problem is visible? Yeah, so please see a thin cylinder shell 1 meter in diameter and 3 meters long has a metal thickness of 10 mm. If it is subjected to an internal pressure of 3 Newton per mm square, determine the changing length, change in dia, and change in volume by taking Young's modulus as 2.1 into 10 power 5 Newton per mm square and mu as 0.3. Tell me which formulas are going to be useful to calculate the changing length, change in dia, and change in volume. Here, ఏం ఫార్ములాస్ వాడాలమ్మా?
Strain formulas.
You just so simple. You have to use the strain formulas to calculate this, isn't it? So let's use them and let's do the problem. Let's write down the given data. Amateur given data, you can do it parallelly along with me. So the cylindrical shell is given, right, of length 3 meters, and the diameter is given 1 meter in diameter, and the thickness of the cylinder is given as, what is the thickness? 10 mm, and the diameter is given as how much? 1 meter. Okay, so diameter is 1 meter, length is 3 meters, thickness is 10 mm. So with this, calculate straight away by using these formulas. PD by 2T, longitudinal stress, PD by 4T. So calculate and tell me the answer, Sama.